Alright, so yeah, I'm back and naman daw maglaro ngayon. I don't feel like playing or doing shit right now. So let's proceed with problem 15. Before that, sabihin ko lang na I've already uploaded the project in GitHub. So makalitaan nyo meron ng marker yung aking project that it's already committed in a Git repository. Anyway, next problem. Okay, so that problem. So we've got starting in the top left corner of a 2x2 grid, there are 6 roots. Without backtracking to the bottom right corner, how many roots are there in the 20x20 grid? The thing with this problem is that it's, well, if you do a bit of mathematical analysis, you'd be able to solve this without using a computer. However, since we want to freak ourselves out, we're going to do not so efficient solution, but it's a brute force solution it's a not so normal brute force solution. We're going to use recursion. So what do you mean recursion? Well, we're going to follow this approach. So here we have our basic algorithm, which is, so we have search. This would be our function, and it accepts x and y coordinates, and yeah, just accept x and y coordinates. So first it's going to search right if x is less than the limit max x. So if it's 2, it's not going to search right. Then it's going to search down if y is less than max y. So it's going to search down if it's not at the bottom. So it's going to search x plus 1 y. Let's leave the coordinates later on. Then search x y plus 1. Then anyway, let's do this. If it's already in the end, if x equals max x and y equals max y, let's do the total paths plus. So you increment the total paths. So we're just going to call this over and over again until, well, we run out of until the entire thing finishes. So how does this work? Well, so we start with search 0 0. The limit is 2. So start here 0 0. Then it's going to call search 1 0, and under search 1 0 it's going to go search 2 0. So this is the stack trace. Now at search 2 0 it doesn't have a forward, so it's going to go down. Search 0 2 1. 2 1 doesn't go down, so it's going to go search 2 2. But with 2 2 it's going to increase by 1. So it's search 2 2, it's already finished. So you go back to search 2 1. The level of search 2 1, it doesn't have any other level. Search 2 0 doesn't have another level. But with search 1 0, you have the option to go down. So when you go down, this is the go left, go right, this is the go down. So instead of 2 0, it's going to go 1 1. Then we go to 1 1. So here 1 1, we go to the right. So 2 1. Then with 2 1, yeah, it's pretty much like that. But when we go down from 1 1, we can go down with 1 1, so this would be 1 2. So this is, you would notice that this whole stream is this first path. This stream followed by this step, these steps would be this path. Now we're going to go this path. We're just going to follow the search right, search down. So yeah, so 1 2 already here, and 1 2. Again, 1 2 doesn't really have a down. It just has this. Just has this 2 2, and again 2 2 is plus 1. So we're finished with 1 0. This already 2 paths. And we already exhausted those 2 paths. Now we go here, search 0 1, which is this path. Again, it's going, at this point you can go right, at this point you can go down, but we're going to go right. And going right, we can go right again. 2 1, and with 2 1, well, it's no choice there. So 2 1, no choice, but 1 1 you have a choice, which is to go down. But when you go down, you really have nothing. Yeah. No, 1 2. Like this one. Then we also have the search 1. Instead of search 1 1, you could go 0 2. But with 0 2, you're pretty much limited to going this path. And we just go that path. So that's it. 6. Using the recursive solution. So let's see how we do it in Java. So I've increased the font size because, well, so that it could be readable at lower resolutions. I think this shouldn't take long. Freak. Int that's equal. So yeah, we could actually do it here. Start here. So private search max x equals x, max y equals y. Search 0, 0. Private void search if x equals max x and y equals, who cares, max y. So we end it. Instead of that, let's test the paths. X is less than max x. Search x plus 1, y. If y is than max y. Search so if you're a noob and you don't know recursion is simply an algorithm or program that can call itself, recursively call itself. By recursively you mean, calling itself. So there are some coding books, programming books that joke about recursion, and in the index they say what is you look for the page about recursion. It's going to say C recursion, C something. It's just going to be calling itself. You know, exhibit YoDog, YoDog, and something for the paths. Source, generate, getter, and setter. Just get the paths. What? That is wrong. Get paths. So let's test it out. Problem 15. Prob equals new. Problem 15. Start with 2, 2. This is out. Prog dot. That's okay. See if it works. 6. So 20 by 20. Hopefully this isn't really that big, but if it takes way too long, well, we're just going to go for the mathematical solution. Yep, it's taking way too long. Oh god, this is so wrong. Anyway, I just took a look at the what do you call this, the cheat sheet, and it's a pretty big number. Probably take a minute or two, or whatever. Let's see. One, two. If it's 3, 4, 5, 6, 7, 8, 9. So it's a billion. If it doesn't reach a billion, we're going to have to do the mathematical solution. Okay, so that's 1 billion paths. That's 3 billion paths. Anyway, it's taking way too much time. I think let's go with mathematical solution. So that's the recursive solution. It's going to be good for very small values, but for very long values, it's going to be stupid. Instead, we're going to go with what we call the dynamic programming solution. It's going to do something with the memoization thing that we did before. So yeah. So think of our 2x2 grid as an array that is 3x3. So that these are the paths. Let's make it bigger so that it's a bit easier to see. So we could start from the end and calculate how many paths are there to this end and move backward. So for instance, here we have one path. Go here, obviously there's only one path there. Obviously there's one path there. However, when you're here, you could calculate it by adding the number of paths available to you. So this is 1 plus 1, that's 2. So here you have still one path. Also here, this is one path. And when you come here, you have 3 paths. Right, because you can either go here where there are one path, there's only one path, and you can go down, which is 2 paths. So 1 plus 2 would be 3, and when you come here, it's 6. And you would quickly realize that this is the Pascal's triangle, right? But I think we could easily, call this. Again, there's what do you call this? It's not a theory. It's a formula to calculate the nth value of the Pascal's triangle. But for our case, we don't give a shit about that. So we're going to do a brute force Pascal's triangle. So we're going to change this, refactor this, name this to Recursive. And let's create our new problem 15. But still, we're going to do the old shit. Who cares? Let's do some stupid shit. Not going to initialize it, we're just going to do it directly. Static. X and Y. Public static. Public static long int. So we have a long two-dimensional array. Long grid equals how the fuck do you initialize everything to 0? Kalimutan ko na yung aking SCJP. Pero I think 0 naman yan lahat eh, no? Who cares? So we start with the first one. Long 0 equals 1. Then we go long shitty road, alternating between the, not really alternating, but okay, let's go horizontally, then we go, okay, we go the upper triangle, then we go the lower triangle. So for int call equals 0, call equals 1, call less than x, call plus. So we're going to go upper triangle would be for int row while it's than or equal to 0. I'm thinking we're going to go start from here. We're going to reverse reverse the whole thing. So we're going to start with here. This is going to be 1, 1. So our column would be this, column 1. God, this is so serious, so fucking stupid. God. So we start with the row. So column 1. Then while the row is, God, my nose. So while the row is doesn't equal 0, it's just going to do its shit. It's not 0, it's not, as long as this greater than row minus. See. No. More. Anyway, how do we do this? So row is column. This is going to go up. So it's going to be 1 0 0 1. Here it's going to be 2 0 1 1 2 0. But how? All equals that's absolutely useless. That's the current column anyway. So what now? Oh my god, I'm nose bleeding. Oh fuck this, I'm nose bleeding again. No, not because of Java, but because of my freaking sinuses. Oh, there's a metallic taste of blood. And I'm freaking streaming. My god. Okay, we're going to just... I'm going to stitch this video after I deal with my nose bleeding like fuck. Anyway, see you in the magic of video editing. I'm going to see you in a couple of seconds. Okay, so the bleeding seems to have stopped. So we proceed. Grid row var call equals. So we're going to go for the top. What's the top? We're going to check the top. So we're going to go opposite. So this is going to be 1. This is going to be yeah, we're going to check the top first, then the left. So Okay, we're going to check the left first, because if x is greater than x is greater than 1, yeah, row call is greater than 1. God, this sucks. If it's greater than 1, it's going to be, the row is greater than 1. We could check the previous one. Otherwise, it's going to be 0 plus okay. And that's that. This upper triangle, it's going to go from current column equals 1 up to column is less than x. And yeah, columns less than motherfucking x. Let's go with because if you're going to stop here, it's going to be less than x. Because for instance, this is 2. So 2. Wait. So this is 2. We're going to make a 3x3 grid. The column would be going from 1 to less than x. Oh god, the blood. No more blood. Just red stained mucus. So 1 to oh god, what the fuck? This is 2. This is 2. Column is less than 2. I think that makes sense. When it reaches this, it's already finished, so yeah. We're going to go the opposite way. Column is equal to x. Column is man, that's no, row is equal to 0. Row is less than or equal to x plus 1. No, x. We're going to start here. The row is this. Then we're going to go down. However, column would start from 0 up to Up to what? Column would go from 0 up to what? Or int call equals 0. I think we could go with column is equal to x. It's going to start from the x and it's going to go down. Again, we're going to start here. Row is equal to 0, column is equal to x 20. So this is so 2. No, so start with y. So we're dealing with squares, so there's really not much of a difference. All greater than 0. All minus. And row equals it's similar, so we're going to start here. So the current row is 0, current column is y, but if y is 1, oh god, I got the row and column switched. They start with 0, 1, I think we're wrong with this one. You stop when you reach your shit. What's the good condition? So 0, 1 0, 1, 2, 1, 2. Start with that. What about the current row? What's the pattern with the current row? The pattern with the column is that it's always going down. It's going to go from 2 down to whatever. Yeah. However, its counterpart, the current row, it's based on the row. We can just bullshit it and see if this works. I'm thinking it won't, but doesn't hurt to try. Okay, so column is the next column. I don't feel like thinking about it. Let's just go to the bug roots. Oh yeah, current. It's 1 0. Yeah, row is greater than 0, and row minus 1 is equal to 0, 0. The grid 0, 0 is 1. Huh? What? That's crazy. Huh? Oh god, this shit. Shit. Yeah, it's 137 billion 846,528,820, and we're going to delete this shit. Anyway, that's it for this run. This is Bride, not bleeding noses. Signing off again.